Hey guys, thank you for joining the webinar today on AWS X-Ray. My name is Abhishek Singh. I'm a Senior Manager for Product Management at AWS. So let's get started with our session here. So in reviewing what you should expect from the session, we'll talk about an overview of AWS X-Ray, so what the service does, why you should be using it, and why we built the service. We'll look at the use cases in terms of what you can achieve using the service. We'll quickly cover the concepts just so that you have the terminology available, and then you can do Google searches and things like that, for example, if you want to learn more. We'll talk about how do you get started using the service. We'll do a demo to show you what the service is capable of. And finally, we'll take a few questions towards the end. So let's dive right in. So as I mentioned, we launched AWS X-Ray at re:Invent in 2016. So that was December of last year. And one of the reasons we launched the service was we were getting a lot of feedback from our customers. So I was product manager for a product called Elastic Beanstalk at the time, which is our platform as a service offering. And we were getting a lot of feedback from our customers as they were moving to microservices or serverless architectures that was very difficult to debug applications once they were breaking them from monolithic applications to service-oriented applications. And as part of our process of thinking through the problem, we realized that distributed tracing was the appropriate mechanism to solve that problem. And that's part of the reason why we went ahead and built AWS X-Ray as a service, which provides you distributed tracing capabilities and then enables you to debug your applications at scale. So let's quickly look at what the traditional debugging workflow looks like. So today a developer writes some code. They do some local testing, and as part of the local testing, they write outputs to a log file so that when they put this code in production, they can go look at the logs and understand what is going on. Similarly, once they've looked at the logs, if they find any issues, the developer essentially starts debugging the code again by adding local breakpoints. And then once they've figured out what the issue is, they add additional log statements so that they can keep track of this issue in the future using logs. And then the process essentially repeats over and over again. And as I mentioned, the feedback that we got from customers were pretty loud and clear that the traditional process of debugging wasn't scaling well for production applications or for those built using service-oriented architectures. And the feedback really was that the process was tedious, repetitive, and time-consuming. And that's part of the reason why we built X-Ray as a service to help solve this problem for you guys. So in terms of the move from monolithic to service-oriented architectures, there's a ton of benefits, as most of you may be aware. For those that are not aware, I'm quickly going to walk through them. But I want to start with the drawbacks of monolithic architectures, if you will. And part of the reason why there's this shift in the industry today of folks moving from monolithic to service-oriented architectures. So with monolithic architectures, it's hard to iterate fast. What I mean by that is you've got this large application that multiple teams are touching at the same point, and it's very difficult to sort of coordinate things across different teams and be able to still iterate quickly without breaking things. Similarly, because you've got multiple components all being shipped as a single monolithic application, it's hard to scale various pieces effectively or efficiently. And so by breaking them into microservices, you can do that. CI/CD becomes time-consuming for monolithic applications because you've got a large application that might take hours. I've even heard of applications taking days to go through their build and test suite, at least the large monolithic ones. And then due to most of what I mentioned, there are reliability challenges, in essence, of deploying these applications properly and in a reliable fashion without impacting end users. And so because of these reasons, what we're seeing is that customers are moving to service-oriented architectures. And as part of that, customers are seeing benefits like increased agility. So by breaking down the application into small bits that are owned by different teams and allowing the teams to move, in essence, own their own piece and move at a faster pace because they only have to worry about their piece. And the interface between these services is a well-defined, REST API, for example. Similarly, because these pieces have been broken down into multiple pieces, they're easier to scale individually, and you can scale the different pieces based on the needs of those individual pieces instead of worrying about scaling a large application. Both of these points lead to improved innovation because your teams can now move faster. And because teams are now responsible for smaller pieces of code, there are less chances of human errors. So just some of the reasons why folks are moving to service-oriented architectures, the benefits that they get from it. Similarly, along with the benefits of service-oriented architectures, there are challenges that come with service-oriented architectures because you now have a large number of pieces that you have to manage and you have to deploy and you have to debug through those pieces. So something that essentially used to run as one now may run as 10 pieces, or may run as 100 different microservices, or maybe even 1,000 microservices. So now you have to keep track of more moving parts, and that becomes a challenge in itself. So AWS provides a whole host of services that enable you to deploy and manage a large microservices application or serverless application. So we've got services such as AWS Lambda, the EC2 container service, AWS Elastic Beanstalk, and CloudFormation. However, it's still difficult to debug application issues in production for various reasons. I would say the most common one being that developers are used to either logging statements or adding breakpoints. And in a production application, it's fairly difficult to add breakpoints because if you start adding a breakpoint and start debugging things live, you're essentially going to time out things up and down your stack. Additionally, you've got in the world today, most folks developing applications with different language stacks, different application stacks. So there's different log formats for each of the particular programming languages or frameworks, for example. And it's very difficult to collect, aggregate, and collate logs from these varying services written in varying different languages and make sense of all of it as one single request or one set of actions that a user is taking for your service. And so the world today looks somewhat like this, which is essentially taking a log-centric approach. So a user makes multiple requests to various services, and as part of that individual services log, the response or metadata around those requests into individual logs. And there really is no good way to correlate these. And most customers I know of are usually using something like an Elk stack, which is Elasticsearch, Logstash, and Kibana stack to get metrics from logs and things like that. All that is great, but metrics in essence are essentially reactive indicators of what's going on, right? So once a metric flips to a value that you don't want it to be at, you know that something wrong's already happened, and then you have to go kind of follow backwards from there and debug your issue. What X-Ray does is essentially flips that approach of log-centric approach on its head and takes a more user-centric approach. So in X-Ray, you essentially, what you get is log lines, if you will, to some extent are comparable to traces. And traces consist of, the individual pieces that make up a single request response to the user. So in this case, what we're seeing essentially is that I have a trace that represents the end-to-end request response. And then I've got various services that individually are logging data, if you will. So in this case, for example, the API gateway sends data to X-Ray, Lambda sends data to X-Ray. I've got the queue sending data to X-Ray, and then DynamoDB transactions, the data is coming into X-Ray. And what X-Ray does is it collects these logs, it collates them, and then it presents a singular view of this individual transaction so that you can go understand what happened as part of this transaction. Now, in terms of how X-Ray helps you, so some of the use cases around X-Ray are identifying performance bottlenecks. So if you've got an application, for example, that's running into slow database queries, you can find that quickly and easily with X-Ray. X-Ray helps you pinpoint specific service issues. So as I mentioned, when you break your application from a large monolith into microservices, or maybe you just started with microservices, it's very useful to understand where issues are originating, if you will. And what X-Ray does with its service graph is essentially show you a visual representation of where an issue may be originating. And so it enables you to pinpoint that issue to specific services. The third use case around X-Ray is identifying errors and exceptions in your application. So X-Ray automatically collects any exceptions that are thrown in your application, and it logs them into individual transactions, and then you're able to go find those errors and figure out why exactly they happen. And we'll see each one of these use cases in a little more detail in screenshots I have, and then we'll look at how to use X-Ray to achieve these use cases in the demo that I'll present. The fourth and the most important aspect of X-Ray is that anything that happens in your application can be correlated back to a user. So if you are emitting or logging user information as part of X-Ray, you can take every single issue, performance bottleneck, or exception and track it back to the user that experienced that error. And so that is by far the most important value that I think X-Ray provides, is being able to tie back application issues to users of your application. So we'll start with concepts so that we are on the same page in terms of terminology, and then it'll just be easier to go through the rest of the slides. So the concepts in X-Ray essentially are a trace. A trace represents end-to-end data related to a single request across services. So as I showed you guys in the picture earlier, if I had an application that was talking to an API gateway, Lambda, and then did some writing into DynamoDB, and then used another service like SNS to send notifications, that entire transaction end-to-end is represented as a trace. Segments are portions of a trace that correspond to a single service. So in essence, traces are made up of segments, and segments represent data collected from a single service. So in the example I used previously of the API gateway Lambda, the segments would be one from API gateway, one from Lambda, for example. Similarly, subsegments, as the name suggests, are pieces of segments that represent remote calls or local compute sections where you want to gather timing information from a particular service. So here again, and I'll show you guys graphically what this looks like, so just so that it's much clearer. But essentially, subsegments make up segments, and then segments make up traces. And each one of these pieces are essentially just building blocks for recording either remote calls or local compute sections, and then aggregate those into a notion or concept of services, and then a collection of services talking to each other essentially represents a trace. The fourth concept that we have here is the concept of annotations, and I think this is fairly powerful in terms of what it enables customers to do. So annotations are essentially business data that you can attach to a trace as a key value pair. The key can be a string, and the value can be a bool, int, or a string. And the value in annotations is that they can be, or they are indexed, and they allow you to search for transactions based on a specific value for annotation. So a use case here, for example, would be, imagine you're Amazon Video, and you've got a whole host of different clients, and you've got, various customers. And assume that you're launching a new service. So maybe we're launching, HBO Go on Amazon Video tomorrow. And as we launch it, we start seeing errors in our application, or an increased number of errors, I would say, in our application. With annotations, I can very quickly go in and start looking at the value of my, client annotation or the value of my user annotation, and very quickly identify if all the errors are happening, for example, from a Fire TV stick that's running a version of the firmware that was 5 years old, for example. The value of annotations is pretty rich in that you can apply business process data or business data to tracing, and then be able to use that to track back any impact in your application to users or to different clients. Similar to annotations, metadata is also business data that you can attach. The two differences between annotations and metadata is that annotations are indexed, metadata isn't. So you cannot use metadata to search for transactions. The other difference is that metadata allows you to store objects in the value instead of just strings, ints, and bools. So essentially enabling you to add richness to the trace, add more context to the trace. The next concept we have is a concept of errors. This is essentially a normalized representation of errors and exceptions that happen in your application. Again, adding more context to a trace and then being able to track back what happens if there was an error thrown. So essentially determining causality in a request graph and then being able to pinpoint which service that error generated from or originated from. The final concept that we need to understand as part of X-Ray is a notion of sampling. And X-Ray provides a fairly rich sampling capability. So besides being able to sample at just a percentage level on services, what X-Ray does is it takes more of a request-centric approach or a URL-based approach. So you can go in and specify things like, post on my payment API gets sampled at 100%, get on my front page or my root page gets sampled at 0.1%, for example. Additionally, you can do things like specify a reservoir rate. So what that means, in essence, is if you have an API that doesn't get hit very often, you want to make sure that you're sampling that at least at a very fixed base rate. And so with reservoir sampling, you can go specify that capture at least one request per second on my front end, and then if it goes above one request per second, then I want to sample at 0.1%. And what this allows you to do, in essence, is make sure that you have the right level of statistical significance when you're capturing data. X-Ray does support 100% sampling, so if you do want to not sample or sample at 100%, you can do that. Sampling is optional. From the service perspective, we really see sampling as a mechanism to control your costs, if you will. So as promised, I'm going to walk you guys through a graphical notion of the concepts. So here what we've got is the same picture that we saw before. And we've got a notion of a trace, which is the end-to-end request response. We've got a notion of segments, which is individual service representations. So in this case, I've got a segment for API Gateway. I've got a segment for Lambda. The question you may ask is, why is Amazon SQSQ and Amazon DynamoDB not represented as segments in this picture? And the reason for that is the Amazon DynamoDB service is not instrumented today. Similarly, SQS is not instrumented. And so what we're going to see here is because I'm making these calls from Lambda, I'm only getting a client-side perspective of these services and not the server-side perspective. And because of that, the calls to the services will be represented as subsegments. So what I have here essentially is my trace, which starts with these two subsegments to SQS and DynamoDB. Then it becomes this segment from Lambda, and then the two segments from Lambda and API Gateway combine to form a trace, right? So again, an end-to-end view of what happened as part of this transaction. All right, so now let's dive into the use cases and see what X-Ray can help you with. So to start off with, what X-Ray helps you with is visualize the call graph. And the idea here really is, enable you to quickly understand your service dependencies in a microservices architecture or a service-oriented architecture. And once I have my list of dependencies, each of the circles there represent the notion of health, if you will, for each of those services. So in this picture, I can very quickly see that I have some issues on my DynamoDB table, which then propagate up to my API and then propagate further up to my front end. So very quickly, by looking at this picture, I can read, a few different pieces of information. And I'll get into sort of what those pieces of information are in the demo in the interest of time. So from visualizing the service call graph to understanding service dependencies, X-Ray enables you to do that very quickly and easily. Now, once I've identified issues, for example, let me talk about identifying user impact. So when we were looking at use cases, I mentioned one of the most important things that X-Ray provides to you is the ability to tie back issues or exceptions to particular users, or being able to quickly, in essence, answer the question, what percentage of my users are impacted? So in this case, what I've done is I've actually clicked on the service map on the front-end API or the front-end service, and then I've switched my group by to status code so that I can measure the impact. And what you're seeing here essentially is that about 1% of my customers are impacted by 500s, 2% roughly are impacted by 404s, and then another 2% are impacted by 409s. So in total, about 5% of my customers are impacted by problems that I need to go figure out. And then roughly the 95% between 200s and 201s are doing just okay. So here, what I'm going to do is I'm going to start diving into the 500. So let's actually click on the 500. Actually, let's go back and look at the performance impact here. So I'm going to go back and switch the view to URL because now I want to look at performance issues. And when I switch to URL, what I'm seeing here is, in essence, the average latency. So what I've got here is my remote signup URL happens to be fairly slow. It's taking 3.5 seconds. And then I've got the front page, which is 1 millisecond, pretty quick. And then blog happens to take 0.6 milliseconds. So if I were looking at this from a performance perspective, I can actually go click on any one of these URLs. And once I click on the URL, the filter expression up top here on the bar is updated. And then what I get down below is a list of transactions that match that criteria. And the criteria up top is that show me all requests that went through my front end and that had the URL front end / remote signup. And so once I have that, I can actually go in and look at the slowest transaction that I found, which in this case is 25.9 seconds because I've sorted on latency. And then I can click on it and take a deep dive of what's going on. So in this case, what I'm seeing is essentially that I had a transaction that came into my front end, which then sent it out to my API, which then hopped over to the API, which happens to be a different environment. Then the API itself does a write to DynamoDB and then publishes the email using SNS. And so what you see here is that most of the time spent in this timeline is spent in DynamoDB, so I can actually click on that. And once I click on that, what I get is a resources view, which essentially tells me that I have a put item call that was made in US East 1, that was made to this particular table. And then the important thing to note here is the number of retries. So anybody who's used AWS SDKs long enough should know that there are retries built into the SDK. And every time a retry happens, there's an exponential backoff that happens. So for example, the first time you make a request and it fails, we wait for a second, for example. And then if you make the next request and it fails, we now wait for 2 seconds. If you make the next request and fail, we now wait for 4 seconds. So essentially, by the time you get to number 10, you've waited a lot of seconds, and that's part of the reason why you saw the 25 seconds there. Similarly, going back to sort of pinpointing issues, if you remember the 500s, If I click on the 500s, I can then get a filtered list of 500s. I can go click on the timeline. Here I see a bunch of red because it's a server-side error. So similarly, again, it starts with the DynamoDB table. So I can click on that. And in this case, because I have an error, it opens up with the exceptions tab. And what I see here is the actual message that was thrown as part of the error, and then a stack trace that shows me exactly what line of code this error was thrown in. So again, very easy to debug issues, pinpoint them to very specific services, even to the line of code where that request was, or where that error was thrown. The next thing I want to quickly talk about is for services such as AWS Lambda, which is a managed AWS service to run your functions. X-Ray is already pre-integrated with the service. It's fairly easy to turn on tracing. You simply go turn on active tracing as a configuration for a function. And once you have that turned on, you essentially see this breakup between the Lambda service itself as well as the Lambda function. And what you see here is essentially that this is a synchronous call to S3, which Lambda spent 186 milliseconds basically from the time it got the request to the time it actually started doing anything with it. Then you've got 1.8 seconds for the request or the invoke to complete. And then the difference between the start time of attempt 1 and the start time of the initialization line is essentially your cold start time in Lambda, which is essentially the container initializing for your request. And then the initialization line represents the time it took to run the init code for your function. And then finally, what you see here is that my code goes and makes a put object call to S3, which returns a 404 error. And then similar to the 500 issue that we debugged, if you hover over this, you end up getting, in essence, the error message here. So in this case, I'm trying to write an object to S3 bucket that doesn't exist. So again, very quickly, I was able to figure out what was wrong with my application and then understand that. So now that we've walked through the main use cases, let's look at some advanced use cases. So the first advanced use case is that you can use AWS X-Ray off cloud. Now this is something that folks don't know. It's not widely understood. It's not widely sort of known. But X-Ray is, in essence, agnostic of the platform that you run it on. So you can use X-Ray with applications running completely on-prem or in your data center. You can use X-Ray with applications, in your developer desktops, for example. You can use X-Ray on different cloud vendors. So we really don't care where you run our SDK and our agent, as long as that environment has access to our AWS APIs and has the appropriate credentials to write data into the AWS X-Ray APIs, you can actually use X-Ray. Next is the notion of a custom payload. So in X-Ray, we've taken great care to document both the input format of the data and the output format of the data. And we actually make the raw data available to you so that you can build additional applications on top of X-Ray. Similarly, on the input side, we provide a list of SDKs that we will cover very quickly in the next few slides. But at the same time, using our document schema that we've published in our documentation, you can actually write your own SDKs or instrument your own frameworks, instrument your own workflows. So it's fairly powerful capability to be able to, instrument arbitrary workflows and be able to send that data into X-Ray. The third advanced use case is the notion of deep linking. So the X-Ray console supports deep linking for every single view that we have, and you can programmatically create these URLs or URIs. So for example, if you're storing your logs in CloudWatch logs or in Splunk or in Elasticsearch cluster, you can actually store your trace IDs and then automatically generate in your Kibana dashboards a hyperlink that links back to that transaction or trace in X-Ray by programmatically generating a deep link. The fourth capability is the use of filter expressions. So in the use cases slides, as I was clicking through different things, the filter expression on the top was being automatically generated for me by the console. But in the demo, I'll walk you guys through the full capabilities of filter expressions, and we'll see how that looks and what are sort of the advanced use cases that opens up for you. And then finally, everything that I'm going to show you guys as part of the AWS Management Console for X-Ray is available via APIs. So our console uses the public APIs. So definitely a lot of different applications, dashboards, use cases that you can, in essence, build or achieve using our APIs directly. All right, so let's dive into how does AWS X-Ray work. So the way X-Ray works is you start off by installing Daemon in your environment that essentially acts as a buffer, and it sends data back to the AWS X-Ray service. Now, once you've got the Daemon installed, you then instrument your application using our SDK. And what the SDK enables is essentially automatic collection of metadata around certain transactions or requests that your application is making. And the Daemon then collects that data, ships it over to the X-Ray service. The X-Ray service collects and collates the data across various different services that might be sending data for that same transaction. So that's why you see a notion of a funnel. And then using the trace ID, we essentially aggregate this data over a period of time to generate an aggregate view called the service map. And what the service map enables you to do is very quickly find needles in a haystack. So you might be sending, hundreds of thousands of transactions per second, or maybe millions of transactions an hour into X-Ray. And there's no possible way that a human being is going to be able to sort of find, one transaction that's important, or the 10 transactions that are important out of those millions of transactions. And so what the service graph does is it very quickly enables you to find services with problems and then dive deep into those services and really understand where your problems or issues are occurring and find those, 1 or 10 transactions that you need to pay attention to. So let's look at each of the individual components that I mentioned before. Let's talk about the X-Ray SDK. So as I mentioned, the different components that you interact with are the SDK, the daemon, and then the service itself via the APIs. So the X-Ray SDK is available for Java, .NET, and Node.js. These are available as GA. We also have SDKs for Python and Go available in beta. And we're working on SDKs for other languages that we hope to release over time. But what the SDKs essentially do is add filters to automatically capture metadata for calls that your application is making to AWS services that use the AWS SDK. Remote calls to non-AWS services over HTTP or HTTPS. This is, again, one of the points that folks miss. So, for example, if you're using a third-party API, imagine login by Facebook, you can actually track or trace those calls using X-Ray, as long as you instrument the HTTP handlers. Additionally, you can instrument calls to databases. So we support popular libraries for MySQL, Postgres, and DynamoDB. And then we also support queues in terms of Amazon SQS. As I mentioned previously, SDKs enable you to get started quickly without having to manually instrument individual calls to be able to log your metadata about requests. So let's quickly talk about the daemon now. So, the SDK essentially sends data to the daemon. The daemon essentially is simply a circular buffer. What the daemon does is it collects data over UDP from the SDK, and it flushes the data to the backend every second or when the local buffer fills. And as users, you have control over the buffer size. By default, we use, I believe, 10% of the memory, system memory that's available. but you can happily configure that to be more or less. The daemon itself is available for Amazon Linux, RHEL, which is Red Hat, Ubuntu, OS X, and Windows. So again, supports a variety of platforms. The daemon can be run anywhere as long as AWS credentials are provided. So you can, for example, run it on EC2. You can run it as a container on ECS, on Kubernetes, on Docker Swarm. You can run it on-premise. You can run it on a developer machine. We don't really care where the daemon runs as long as I mentioned previously, that the credentials are available to the daemon, and then the machine that the daemon's running on has access to write data to the AWS APIs for X-Ray. So in a graphical sense, the X-Ray workflow looks somewhat like this. So you've got your DevOps teams or your developer teams accessing the X-Ray console over HTTPS using the AWS Management Console. You've got applications that are instrumented. So here, the scenario essentially is a hybrid application that runs, maybe one service on EC2 or AWS, and then the other piece runs on on-prem or your own data center, for example. Or maybe it's a developer machine where you're testing, a new service against a production service, for example. So what you're seeing here essentially is that, the different pieces connect together, send data into the X-Ray API, which obviously runs in AWS, and then the X-Ray console enables developers to quickly understand what's going on there. So now let's look into the APIs and understand what the APIs do. And we'll do a cursory sort of look through the APIs. If anybody's interested in further details, we have fairly extensive documentation, so feel free to search the names of these APIs on Google, for example, and you will definitely find the right documentation. So the X-Ray APIs essentially enable you to send, filter, and retrieve trace data. So as I mentioned previously, we document the inbound format. So if you don't want to use our SDKs, or you want to instrument an application that is written in a programming language that we don't support today, or a framework we don't support today, you can actually just send the data directly using that published schema to our API and use X-Ray that way. So you don't actually have to wait for us to support a specific programming language, for example. Similarly, we provide or we give you access to the raw trace data using batch APIs, so that if you wanted to collect this data and store it in a third-party system, store it on your own storage, store it in S3, you can do all of that. So we're essentially providing a very transparent pipeline, if you will, where you can write data if you write it in the format we expect, and then extract data, the full raw data that X-Ray stores for you. And then finally, using the APIs, as I mentioned before, you can create your own data analytics applications on top of X-Ray. So today, on the X-Ray team, we think of the service graph as an application, and then we think of the timeline view that I showed you guys before also as an application. And over time, obviously, we'll build additional applications, but we're very excited to be able to provide customers with this set of APIs that open them up to be able to do innovative things and build innovative applications on top of this data. So let's look quickly at the APIs themselves. We've got 4 APIs. There is put trace segments, which enables you to upload the trace segments to the service. There's batch get traces, which enables you to retrieve the full raw traces specified by specific IDs. There is a get service graph API that returns the service graph as JSON, and it also includes histograms, sparse histograms, I should say, for each of the services. So you can actually look at the timing information beyond just the average response time. The final API that we want to quickly review is get trace summaries. Essentially, what this API enables you to do is filter and search for specific APIs, or specific traces, I should say. So in this case, as I mentioned, filter expressions is a fairly rich capability in X-Ray. So you specify your filter expressions in this API, and then what this API returns to you is trace IDs where you can then go retrieve the full traces, and it also gives you some summary information for those traces so that most of the times you don't actually have to go retrieve the full trace to understand what's going on. Wanted to show you guys a quick example of what a segment document looks like. So this is the raw data that you send to the X-Ray API. The X-Ray SDKs essentially generate data in this format. And what you're seeing here essentially is a minimal example which has a name for a service, a unique ID for this document, a start time, an end time, and then a unique ID for this transaction. And the way the transaction ID or the trace ID works, or the format of it, is that the first number there is the version, which is always 1. The next set of numbers is a 32-bit epoch, and then the last set of numbers separated by dashes is a 96-bit unique ID. Similarly, the second use case or the second document here is representing an async transaction, in which case the end time is replaced with an in progress flag. And this essentially allows you to specify to X-Ray that I've started an async transaction, but it's not yet complete. And once the transaction completes, you can override it with the end time. X-Ray today stores data for 30 days, and you can update transactions up to 7 days old. So in essence, you can time any workflow with X-Ray that is up to 7 days long. All right, going back to the sampling configuration. So I mentioned previously that X-Ray enables a fairly rich capability to control sampling. So what we have here is a very simple example of sampling rules. And as you can see in the first set of rules, so this is defining essentially 2 rules, a default and then a specific sampling rule for my payments API. And what I have here essentially is that my payments API is essentially capturing at 100%, and the text here is incorrect, so ignore the 5% sampling. That's actually not true. In this case, the rule is specifying 100% sampling because the rate is 1, and then a fixed target of 0 because since I'm capturing at 100%, I do not need a reservoir. The second rule, which is the default that gets applied for all other APIs, is that capture a fixed target of 1 request per second, and above that 1 request per second, capture at a 10% sample rate. So again, a mechanism to control my costs, really associate values with transaction that I'm logging. But if I don't want to sample, I can just set the default sampling rate at 100%, and that's just fine. All right, so let's quickly hop through the getting started. So going back to sort of the pieces that you need to get started, it's the agent or the daemon, and then you have the SDK. So we'll look at the agent installation instructions quickly. So here is just a screenshot of how you would install the agent on EC2 or any Linux-based system. We have RPMs available on S3, so you can just download the RPM and install it. Similarly, if you wanted to install the agent on Windows, we provide the agent both as a process as well as a service, and then you can use PowerShell to get that installed. And finally, if you wanted to run this on a container, so either on ECS or Kubernetes or any other container orchestration system, you can build a Docker container very easily by downloading the binary that's available again on S3 and then baking it into your Docker file so that you can run it. One thing I do want to mention about container or using the daemon in a container world, we recommend that you run the X-Ray daemon on each host that you run containers on. The reason for this really is that the SDK and the daemon communicate over UDP, which is a lossy protocol, which doesn't have retries built in like TCP. So it is better to run them on a network where the SDK and the daemon are on local network. So that minimizes the chances of any essentially networking issues preventing data from getting to the X-Ray service. And finally, let's look at how you instrument your application with the SDK itself. So the SDKs today require you to do a few things. So here I'm using an example for Node.js. So in Node.js, you have to add the X-Ray SDK package to package.json, and then all the lines that you see in black are the lines that need to be added to your code, regardless of, in essence, how large your code is. In this case, it's an Express example, but what I have here is I start or load in the X-Ray SDK. I wrap a capture statement around the AWS SDK so that the AWS SDK essentially gets instrumented. I have some optional lines here that are setting plugins that I want to use. So for example, in this case, I'm using the EC2 plugin that automatically captures the instance information and the AZ information from EC2. Additionally, I'm instrumenting the HTTP library, and I'm setting a default name for my service. And then I have, in essence, the line here that says app.use xray.express.openSegment. That's loading in the X-Ray middleware into Express. And then finally, the last line here unloads the middleware from Express so that the segments are started and ended as the Express handler processes the various routes, if you will. Finish up with pricing for X-Ray, and then leave you guys with some URLs for documentation and sample apps that you can get started running today. So the way X-Ray is priced is essentially we have a free tier that allows you to send 100,000 traces for free each month. This works out to roughly a little over 1 request or 2 requests per minute, I believe. And then in terms of retrieving data from the system, you can query up to 1 million traces or retrieve the raw data for up to 1 million traces for free. Beyond the free tier, the charge is fairly nominal. You pay $5 per million traces that you record, and then you pay 50 cents per million traces that you retrieve from the system or you query. And I want to clarify the notion of a trace. So one of the things that essentially the way X-Ray is priced is that once you instrument your front end, so assume if it's an API gateway, if you're running an API, it's an API gateway. If you're running a web app, it might be a load balancer or a web tier. But once you instrument the front of your application, everything that you add behind that is essentially free, right? So what we're telling you is that it's valuable for you to instrument the depth of your application, and we want to incentivize you to instrument the depth of your application, which is why we've made the pricing model the way it is. In terms of some limitations that I want to cover here, the overall end-to-end trace size is a maximum of 500 kilobytes of uncompressed data. So essentially, each trace can contain up to 500 kilobytes of data. And that's essentially, you get that as part of an individual transaction. And then the number of annotations is today, I believe, capped to 50 annotations. So you can have up to 50 different indexed fields. So I don't want to cover that, just so that you're aware of those two limits. Finally, as I mentioned, X-Ray is available today. It's been available since December of last year. We went GA, or generally available, with the service in May. So you can run your production workloads on it starting, May. So if you haven't done so, go ahead and check us out. I've got some links here that are helpful if you want to go learn more about X-Ray. I've got our documentation link here. I've got sample apps on GitHub that you can get started with. So I would highly recommend, go give it a shot. Run a sample application, see what that feels like, and then go try it out in your own applications, and give us feedback. We're looking to grow the service, so any feedback that you guys have, you can provide us either on GitHub or you can provide us through our forums. So go ahead and take the next step of running the app and getting us some feedback. Thank you guys very much today. Greatly appreciate you guys spending the hour with us, learning more about AWS X-Ray. It's great that you guys took the time out. Greatly appreciate that, and thank you very much.